So hi friends, இது வந்து third numericals. So we will start discussing about the third problem now. Okay, first we will study the question. A shaft fitted with a flywheel rotates at 250 rpm and drives a machine. The torque of a machine varies in a cyclic manner over a period of 3 revolutions. So every 3 revolutions, so one cycle it is considered as. The torque rises from 750 Newton meter to 3000 Newton meter uniformly during first half revolution and remains constant for following revolution. It then falls uniformly to 750 Newton meter during next half revolution and remains constant for one revolution. The cycle being repeated thereafter. So இதுதான் அவன் கொடுத்துருக்க கண்டென்ட். ஸோ அதுலேருந்து அவன் என்ன கேட்குறான்னா determine the power required to drive the machine. ஸோ ஒரு மிஷினோட கனெக்ட் பண்ணியிருக்காங்க. இந்த மிஷினை டிரைவ் பண்ணணும்னா மினிமம் எவ்வளோ பவர் ரெக்வயர்ட் நம்மளுக்கு அப்படின்னு கேட்டிருக்காங்க. ஸோ அண்ட் ஆல்சோ த பர்சன்டேஜ் ஆஃப் ஃப்ளக்சுவேஷன் ஆஃப் ஸ்பீட் சிஎஸ், ஸ்பீட் வந்து எவ்வளோ ஃப்ளக்சுவேட் ஆகலாம் இருக்கணும் அப்படின்னு கேட்டிருக்காங்க. If the driving torque applied to the shaft is constant and the mass of the flywheel is 500 kg with a radius of gyration 0.6 meters. So first given மட்டும் எடுத்துடலாம். givenல இருந்து என்ன இருக்குன்னு நம்ம கிட்ட one sec. So given speed இருக்கு 250 rpm. ஸோ வேற என்ன கொடுத்துருக்கான்? ஸோ இவன் கொடுத்துருக்க இந்த டேட்டா வச்சு எனக்கு தெரிஞ்சு நம்ம கிராங்க் அவுட்புட் விசஸ் கிராங்க் ஆங்கிள், ஸோ எந்தெந்த கிராங்க் ஆங்கிளில் எவ்வளோ டார்க் நம்மளுக்கு கிடைச்சிருக்குன்ற இன்ஃபர்மேஷன் நம்ம சொல்லியிருக்கோம். இதை வச்சு கிராஃப் பிளாட் பண்ணிக்கலாம். ஸோ வேற என்ன இன்ஃபர்மேஷன் கொடுத்துருக்கான்னா மாஸ் 500 kg, then radius of gyration k 0.6 meters. so இந்த மூணு டேட்டா கொடுத்துருக்கோம் பிளஸ் டார்க் விசஸ் கிராங்க் ஆங்கிள் இதான் வேர்ட்ஸில் கொடுத்துருக்கோம். ஸோ we can convert this into a graph. ஸோ ஃபர்ஸ்ட் அவன் ரெண்டு விஷயம் கேட்டிருக்காங்க. ஒன்று பவர், இன்னொன்று கோஎஃபிஷியன்ட் ஆஃப் ஸ்பீட் ஃப்ளக்சுவேஷன். ஸோ பர்சன்டேஜ் ஆஃப் ஸ்பீட் ஃப்ளக்சுவேஷன் நம்ம கண்டுபிடிக்கணும் CS. ஸோ பவர் கண்டுபிடிக்கிறது நார்மல் ஃபார்ம்னா மீன் டார்க், ஆவரேஜ் மீன் ரெசிஸ்டிங் டார்க் டைம்ஸ் ஒமேகா. இதை நம்ம யூஸ் பண்ணி பவரை கண்டுபிடிக்கலாம். ஸோ we need to know about omega and mean torque. So omega here already given indirectly in terms of speed. So what is the formula for omega? Sorry. So omega will be 2 pi n divided by 60. So we know the value of n. So it is 250 divided by 60. That means omega will come around how much? Okay, 26.2 radian per second. So per second it could go across 26.2 radians. That is the value of omega we got. So I would write this. So we got omega equal to 26.2 radian per second. So from that we can easily find power when we find mean torque from the graph. So the next thing he needs CS. So first thing whenever we need to find any variable, we should get all the formulas related to that variable. Maybe so many formulas are there for fluctuation of speed. We should find which formula will be best suited for this, because when I choose other formulas, many variables will be unknown, so I cannot solve. So when I can see a better formula will be from energy equation, change in energy equation. So del E equal to mass omega square k square Cs. From here I can solve Cs. For Cs I know omega, mass is given, radius of gyration is given, so only thing I need to find is the change in energy, excess energy. That I can easily find out from the graph. So I will take this formula to solve CS. So first, in both the case, I need first to plot the torque versus crank angle drawing. So I will draw the torque versus lags so this I will make it as torque, and here crank angle. So from the question we can clearly know about the graph. So torque of a machine varies in a cyclic manner, so every 3 revolution it repeats the same what is in the previous cycle. So torque rises from 750 Newton meter to 3000. So I can see 500, 750, 1000, 250, 1500, 750, 2000, 2500, 3000. 750 starts here, so it uniformly increases for the first half revolution. So from here 750 it goes to 3000 uniformly. Note that uniformly, that means a straight line. So from there and remains constant for the following 1 revolution. So half revolution means it is pi, right? Half of a revolution in a crank, so it is a pi. The angle is 180 degrees, so it is in radians, it is pi. So half revolution pi. From there it remains constant for another 1 revolution. So 1 revolution means 2 pi from here. So another pi, another here 1 pi. So it remains constant. Then it falls uniformly to 750 Newton meter during next half revolution. So again for another 1 pi for half a revolution it falls uniformly to 750. And during next half revolution it remains constant for 1 revolution. So from here 1 revolution it remains constant. Right? So pi plus 2 pi, 3 pi, then 3 pi plus 4 pi, 4 pi plus 2 So we already did the graph. So to find the mean torque, because mean torque is required to find the power, as we discussed earlier in the formula. So power will be mean torque times omega. So to find the mean torque, I will be to know about the area in this boundary under this line. So I will be finding that and divided by the revolutions, number of revolutions in radian. So that is the formula for mean torque. So I will be finding the area first and then I will do this one. So area, for total area I need to find. So first I will name it 1, 2, 3, 4, 5, 6. So area of, maybe take it as 0 here, 0, 1, 2, 3, 4, 5, 6. I need to find out the area in this enclosed area. So I will split this regions. So I will take this one as a rectangle and these two triangles and this one rectangle I will add up to have the total area. So area of 1, 0, 1, 2, 3, 4, 5, 6 would be, I will name this as 7, 8. Okay. So this area will be 0, 1, 5, 6, 5, 6 plus, this is the area, plus area of 1, 2, 7 plus area of this one, that means 2, 3, 7, 8 plus 3, 8, 4, area of triangle 3, 8, 4. So I need to sum up these areas to find the total area. So first this one, so this is just normal formulas for to find the area. So this is a rectangle, so length into width. So the length would be 6 pi and height will be 750. So 750 times 6 pi, the area of first rectangle, and the area of this triangle would be half into base into height, half. I know what is the base. Base is pi. Height will be the difference between the total torque, maximum torque to the torque in the base of the triangle. So 3000 minus 750. So that will be 2250. Plus area of this box. It is same, height is same, but revolution differs. So 2 pi. So 2 pi times 2250 plus this triangle. It is same as this one. So 2 pi when I solve this, it would come around 11,250 Newton meter. So this is the area, total area which I got by solving. So what I will do is to find mean torque equal to total torque divided by revolution per cycle, that is 6 pi. So when I divide 6 pi from this, so here I missed one pi. Why I took the pi there without solving that, I can cancel it out in the revolution. So this would come around 1875 Newton meter. So this is the average mean resisting torque that the flywheel requires to start rotate. So 1875. So this is 1250, 500. So something about here, the mean torque should be T mean. So this is the these powers will be used by the flywheel. So it will be used. So the excess energy will be here. That is the change in energy. We name it as mathematically. So from here we can find the power. So power equal to T mean times omega. T mean is 1875 times 26.2. So power would be, how much it is coming? Five watt. So this is the answer for the first. So then we will find CS now. I'll drop it. So I need to find CS, coefficient of fluctuation of speed. So I already told you we can find that from this equation. So only thing here we need to find del P. All other things are given. Mass is given, radius of gyration is given, omega is indirectly given as speed. So we can solve this. So to find this area, what I can do is, normal to find this area, I need to know about the geometry, the dimensions of this triangle, the dimension of this box, and the dimension of this triangle. So now I should name this point. Maybe till 8 I have named. So 9, 10, 11, 12 I name it as. So to find this box I can easily find. So the mean torque I know it is 1875. So the height of this triangle and the height of this box remains same. The difference between 3000 and 1875. So that would be around so to find this triangle base, so height we know it is 1125. To find this base, I really use mathematics here. So I will be using similarities of a triangle. So to find this triangle and this bigger triangle is similar. If I can prove that these two triangles are similar, then I can find this base with the similarities formula. So by the ratio of the base to height I can find easily. So I will draw the triangle again here. So 2, 9, 10, 1, 7, right? So to prove this, these two triangles are similar. That means 2, 9, 10 and 1, 2, 7. These two triangles are similar. I will prove like this. These two triangles have the same angle here. and the same angle here. These corresponding angles are equal, and also these angles are equal. So I will prove this triangle as similar with angle are equal, A. So these angles are same for both the triangles, and these two angles will be same because this line and this line are parallel. So I can easily say these two angles are equal, and these two angles are equal, or orthogonal. So from this uh, angle are equal, I can say these two triangles are similar. So their sides, corresponding sides, should be in the proportional, in the ratios. So from that I can write 9, 10. That means this side 9, 10 divided by 1 to 7, the distance of this is equal to the height 2 to 10 divided by 2 to 7. So what will be, I need to know about the distance of this one. So 9 to 10. So 1 to 7 I know it is pi. 2 to 10 I know it is 1127. 2 5 sorry 2 to 7 I know it is 2 to 2250 yes. So from here I can say 9 to 10, the distance is I can solve this and I should get 0.5, 1 by 2. So it is 0.5 times pi. So this is 0.5 times pi. So now I can find this area, right? All the dimensions are known. So I can say about the area of so 9, 2, 3, 12 will be the area of this triangle. That is half into base will be 0.5 pi times the height 1125 plus the area of this one, that is 2 pi times height 1125 plus area of the other triangle. It is same as these two triangles are similar. From the first I know these areas similar, so this should also apply here. This what we did should also be the same here. So I'll use the same 0.5 pi. So the area would be 8837 Newton meter. This is the excess energy, change in energy I got. So I can now solve this equation. Substituting this del E over here, I can write CS, fluctuation of speed, will be, when I solve this, it should come around 0.071, I think. What was the answer? Yes, it was 0.071 is the answer. So I think this explanation will be good to understand. So we will see in the next video.